And thank you so much, everyone, for joining. I'm going to hand it over to Danielle Moore. She is our resident expert for many years. She's been visiting all of Weisburn schools and helping support CGI instruction across our classrooms. The teachers and administrators love being able to work with her. She's such an expert and is wonderful at helping us to brainstorm strategies and move our instruction forward as we work to support students with math. So thank you, Danielle, for being here, and I'll pass it over to you.
Yay, thank you for having me. Thank you for those kind words. So I'm excited because I feel like Cabrillo is at the point where the exact same conversation I'm having with teachers and administrators is the same conversation I can have with parents. Sometimes teachers are not, how do I say, performing in alignment with the ideal situation for a CGI or cognitively guided instruction classroom. But Cabrillo teachers are really doing the work and your kids are in a great space. So like I said, I'm going to talk about some big ideas and definitely leave some time for you to ask questions at the end and throughout. And the same things I said to teachers this morning, I'm going to be saying to you guys so that you can support your kids at home. So I'm going to share my screen. So when I'm teaching CGI lessons, math lessons, I am always thinking about these 5 things. It took me a while to really create a system and articulate it. But one of the things about me is I'm always going back looking at old videotapes of me teaching in classrooms or conversations I'm having with kids. And it is always about one of these 5 things. So when I was working virtually with kids online, we came up with some systems of expectations around our work. So I used my hand. So the very first thing we want to make sure that kids always do when they're reading a word problem, if they're listening to a word problem, if they're looking at a chart or an equation, is we want to pause and we want to make sure that they are analyzing and comprehending the problem. It's going to be very difficult to solve a problem if you haven't taken a moment to look at it carefully and make sense of it. So one of the first things that mathematicians do when they're solving a problem is they analyze it and they comprehend it. I'm going to come back to this one in just a minute. The second thing that kids need to do is they need to make a model of the problem. This model could be an equation. It could be the use of tools where they're actually counting out blocks to solve the problem. It could be something like a number line or a drawing. I don't dictate to kids what type of model they need to use. Instead, I ask them to use a model that makes sense. So if students understand a problem, they can create a model that makes sense for them. The third thing we want kids to do is label their model. So for instance, if they are counting out 5 blocks, they would label it with a 5, or maybe they would label it with the word blocks. Then we find that those labels help kids make equations to match. So if I had 5 blocks and I took away 4, I have 1 left. Those models and those labels are almost a direct connection to the equations that they need to write. I have found over the years that there's not just one way to solve a problem. So some students might think about adding up to find the answer. So for instance, if the problem is 5 minus 1, some kids might think 1 plus some more will get me to 5. Some kids will think about 5 minus 1 equals 4. So that leads us to think flexibly about what those equations look like. And then lastly, we ask kids to verify their answer. They can use another tool to verify their answer. They can use another equation to verify their answer. They can use another model to verify their answer. But in any given math block, they should be analyzing a problem, making a model, labeling the model, creating an equation to match, and then verifying it. And over time, the fingers become a silent message where kids know that there's this system and this process that they need to go through on any given math problem. Are there any questions about that math process?
Danielle, I'm wondering if you could show an example of like what that looks like. So if we had a problem like Mrs. Wilberg has 5 snowballs and Miss Graves gives her some more snowballs. And then Miss Wilberg has 12 snowballs.
Love it. Absolutely.
What would that look like?
So what that would look like, and I'll go through the whole process and then I'll dig into each piece a little bit more. So I'll use a really simple problem for the sake of time. But if the problem is Mrs. Wilberg has 5 balls, 2 balls rolled away, how many balls does she have now? So let's dive in. So as a teacher, probably in K through 2, depending on the student's ability to read independently, but I would read this problem to the kids. So Mrs. Wilberg has 5 balls, 2 balls rolled away. How many balls does she have now? So we would discuss the problem so that I could be sure that they understood it. So I might ask the kids, who's the character? Mrs. Wilberg. What does Mrs. Wilberg have? She has some balls. And what's happening to the balls? 2 of the balls rolling away. So I might ask the kid something like, so is she going to have more balls at the end of the story or less balls at the end of the story? And they'll say less, and I'll say why. They're all because some rolled away. I will not say whether or not it's an addition or a subtraction problem. The reason why I don't say it's an addition or a subtraction problem is because this problem can be solved with addition or subtraction. If your child reads a word problem or a word problem is read to them and they ask, do I add or do I subtract? That tells you that they have minimal operation sense. And I'll write that over here. Operation sense means that when students listen to a math problem, they have a sense of what operation to use. And the best way to develop operation sense is from solving a lot of problems and actually making sense of them, comprehending them. So we talk about the problem, ensure kids understand what's happening in the problem, and then students can build a model with actual physical tools like cubes and blocks, or they can draw it out. So they might draw the 5 balls. They might label 2 balls rolled away. Right, so here we can see their model of the problem. And they might identify that there are 3 remaining. And write a 3. So we comprehend and analyze the problem. We make a model of the problem and we can label the model. Now students can use an equation to solve the problem. So some students might say 5 minus 2 is 3. Other students might say that 2 plus blank is 5. both of those equations are accurate and match the problem. And both can be used to solve this problem. So subtraction or addition can be used to solve the problem. So we've analyzed and comprehended the problem. We've created a model of the problem. We labeled the problem, and now we have equations. We even have an alternative equation. And then I ask kids to verify. How will you verify? Some students might check it on a 10 frame. And this is just for the sake. So they might put 5 balls onto the 10 frame, cross out 2, and realize that there's 3 remaining, which matches this model here as well as their equation. So analyze and comprehend, model, label, equation, verify. Questions about that?
I have a question.
Yeah.
What about when the numbers, I have a first grader, what about when the numbers are bigger and we don't want them drawing 25 balls and adding 10 more? How can we help them solve those problems?
So let's say, for instance, the number is 50 and 23. So if the number's larger, let's say 50 and 23, some students might use base 10 blocks to represent that 50. And they might subtract using these base 10 blocks. So they might subtract 20 and then 3 more and find the difference, which is 37. So that could be an appropriate model. Some kids might use money. So they might use 2 quarters. And maybe they will subtract 23 from that and know they have 2 more left over. So there's different models that kids can come up with outside of circles. Circles are very appropriate for kindergarten. And as just a matter of fact, that's where some kids are. But the introduction of tools like 10 frames, base 10 blocks, money, are great ways to stretch students' thinking and nudge them to more sophisticated representations. Does that answer your question? Second graders might be using a number line.
Yes, thank you.
Any other questions? So that's minus 10. See that? Minus another 10. And on 30, and then. So circles are one way for kids to represent their thinking, but tools. And the thing I love about tools, I love them. I'm in classrooms all over Southern California from all different backgrounds and demographics. But the thing I see about tools is that a lot of kids, it sparks an aha moment in them. For kids who are easily distracted, the tools are concrete. And so if there's an announcement over the loudspeaker or there's a visitor to the classroom, when they turn away and then turn back, those tools are right there so they can go right back to the thinking. And I'll make sure to share an article with Ms. Wilberg and that she can share with all of you. It turns out that students who use tools tend to be far more efficient and effective at problem solving and a increased achievement on test scores. And I will share that information with you. There's an article. So some parents are afraid that students will use tools as crutches, where they're actually more of a tool for nudging them to the next level. So don't be afraid to use tools. Questions about that? So that being said, let's go back to this one more time. So again, when you're working with your kids at home, if you could check to make sure that they understand the problem before they solve it, It's going to make things so much smoother. I'll give you some strategies for that. Making these models are crucial for kids because not so much in K through 2, but in 3 through 5 and all throughout middle school and high school, they have to analyze models and make sense of it, right? It's like looking at charts and data and graph. So creating these models is going to increase their ability to understand other models. Labeling their models helps keep them organized and accurate. These equations, there's multiple ways of solving problems. And so these equations help students connect these models or pictures to more formal mathematics. And then this last one, verify, has been a big push for me this year because I notice when students are done solving a problem, they'll often take it over to their teacher and say, is this right? Did I do it right? Can you check it for me? And so I do believe it is important for students to be able to verify and check their own work. Because when they take a test, the teacher can't verify their answer is correct before they submit it. So do the kids have strategies they know they can use to verify their own work? Are they in the habit of slowing down and double checking their work before they submit it? And this is something students as young as TK and kinder can do. They can count it again. They can pick up their tools and they can put it on a 10 frame to verify, right? So verifying, self-verification, right? Having those strategies in place is going to serve them for the rest of their lives. Does that make sense? One of the bigger ideas that I pushed with teachers this morning and we talked about is we really dove into this first one, analyze and comprehend the problem. And I want to talk to you guys about that because I think it's something you can do at home. So oftentimes in a CGI classroom, we give kids word problems because it teaches kids what math is. So outside of models and equations, those are strategies for solving. We want to make sure that students can represent the problem and understand what it is they're trying to figure out. That often includes word problems. And word problems have some inherent challenges. I think I've faced probably most, if not all of those challenges. And I want to share with you some strategies you can use to help your kids at home. So I'm going to sort of backtrack something that happened to me the other day, or actually yesterday in a second grade classroom. So one of the strategies I use when I'm with kids, it's called stop and jot. So what happens during a stop and jot is I'll read the problem, I'll stop at the period, and kids need to jot down what they heard or what they saw in their mind. So for instance, with this problem, Miss Wilberg has 50 balls, stop and jot. Ideally, the kids would make a stick figure of Mrs. Wilberg, or they might just put a W for Wilberg, or maybe they write her name. And then they might write the number 50, or they might represent 50 with some base 10 blocks. But the idea is that they're going to stop and jot down something very quickly. That makes sense. The reason we want kids to stop and jot as a strategy is because as the problems become longer and more involved, they're going to have to retain more information in order to solve. And something that I notice about kids is that sometimes after reading a whole problem, we'll get to the end and say, what is this problem about? And they have no idea. So they're not really engaging and paying attention to the details along the way. And stop and jot can help them stop and take hold of those details along the way. This works with kindergartners, probably about this time of the year and in the spring. It also works with my 8th grader. Stop and jot is a strategy my 8th grader frequently uses when she's working on math problems so that she doesn't get overwhelmed by all of that information. So I was in a 2nd grade classroom yesterday, and we were working on the stop and jot strategy. and most of the kids were jotting down nothing. And this was my first time in this classroom. These kids didn't do a lot of explaining their thinking and talking about their thinking in math. So this was sort of new to them. But what I noticed is they weren't writing anything down. And when I gave them suggestions about things that would make sense, they were hesitant to speak up. So I had to go back into my toolkit and pull out a different strategy, which was this one: repeat, repeat, retell. So if you think about it, when you repeat something, you have to have actually listened to it. So sometimes I find kids are sitting there quietly, maybe they're doodling, they look like they're paying attention, but they're not really. They're thinking about, I don't know, Legoland or what's going to happen after school that day. So one strategy that's been very effective as a beginning strategy is repeat, repeat, retell. So when I'm working with kids, it might sound like, Mrs. Wilberg has 50 balls. Repeat. And then the kids will say, Mrs. Wilberg has 50 balls. 23 balls rolled away. Repeat, 23 balls rolled away. What's happening is that they actually have to listen in order to repeat. And listening comprehension is one of the greatest skills that kids can develop. So we practice developing those listening comprehension skills by having them listen and repeat. And something I've noticed is that their ability to retell the details of a problem are far improved after they've repeated it several times. So when you're at home with your kids and maybe they have a word problem for homework, one of the strategies you could use is reading and then having them repeat. Reading, having them repeat, and then retelling the whole problem, including the details. You're going to notice that over time, it's going to get much better. Their ability to comprehend and retell is going to get much stronger. Does this make sense so far? So before they can stop and jot, they've got to be able to listen and repeat. Questions about that?
Danielle, what are some things parents can do? So if the students are bringing home a word problem, right, to apply those, what are some ways that families could practice these things or kind of almost create simple word problems on at home on the fly? What would be some tips for that?
So a couple of different things. Before I go there, that's a great question. I'm going to go back to this one. So I love kids so much. They stretch me and they get me to grow in so many ways, including my own child. But yesterday was just an eye opener because we were doing the stop and jot strategy and repeat, repeat, retell. And one little girl who had a lot of personality decided to take her pencil and like bang it on the table. And I said, "What's wrong?" And she goes, "You're not helping me." And I said, "Well, Mrs. Wilberg had 50 balls, but you're not helping me." So she wanted me to tell her exactly what to write, how to write it, and how to do it. And I'm not going to do that because that's getting her to be dependent upon me, who cannot always be there. So what I do want her to depend on is her ability to listen and stop and jot or build with tools. So a lot of times when your kids are asking for that help, the best way to help them is to get them to repeat the story back and draw a model or build it with tools. That is a strategy that will last for the rest of their lives. Listening and repeating and retelling will always work. Stopping and jotting down important notes will always work. And so that's what we want to do. We want to give them strategies that will always work when you, the mom or parent, are not there, or when the teacher's not there, when they're doing their homework, or when they're taking the test. We want them to be able to say, "Oh, wait, can you repeat that, please?" Or "I can stop and jot." That's what we want them to walk away with. Now, in terms of story problems, word problems, I have a bank of them. I'm happy to share those with you. But the other thing is just think about what's going on around you. Oftentimes we think about math as a bunch of random numbers to add and subtract, multiply and divide, when actually math is really a way to describe what's happening around us using numbers. So thinking about it's 8 o'clock, we have to leave the house in 10 minutes. What time will it be? So that time describes our morning routine, right? I really want to be able to get that new Lego at the store, but I've got to get 10 stickers. I have to get 10 gold stars on my chart. Right now, I only have 7. So if you have 7 gold stickers on your chart, how many more do you need to get to 10? Kids can figure out that distance or that difference when it's important to them. So thinking about what you do in your regular day and your routine, you can use numbers to describe those events. And then kids can see that math is all around them and it's not something to be afraid or intimidated by. And that they don't need a textbook to do math. They can look around them and describe the world around them using numbers. Anything else? Yeah.
That was a good point. Thanks, Jen. In my house, we do a lot of how many days until my birthday or until see grandma. And that's been one way that we kind of are bringing in some math thinking on the fly.
Mm-hmm.
I was hoping you could talk in our last few minutes about where students sort of should be at each grade level right now. So if parents are wanting to kind of check in with their student on math, like what sorts of skills would they expect to be seeing at home? And what are those kind of key standards? I know that's a big question.
That is a big question.
No.
Okay. The reason that's a big question is because kids develop their mathematical understanding at different rates. So ideally right now, or it's normal, I don't know if that's the best word, but it's common for kindergartners to be representing everything with individual units or circles or sticks. And the beautiful thing about counting 1 by 1 by 1, and I'm going to see if I can explain this clearly, is that students are learning number and number order, and they're learning that as they count to 5, that inside of 5, there is also 4, 3, 2, 1. That's crucial for the ability to subtract. That every number has another number embedded inside of it. And we can combine those little numbers to make a bigger number. So that helps with counting. It also helps with subtraction. So it's okay if they're counting 1 by 1 by 1 by 1 in kindergarten. You probably also have some kids who are doing that in first grade, and that's okay. What we want to see is first graders moving towards this idea of groups of 10 or base 10 blocks. So instead of making 10 individual little circles, if they can either use those base 10 blocks and know that it represents 10, or they might just make a singular stick and label it with a 10. So really diving in and understanding groups of 10 is going to be important for first graders. For second graders, I think one of the greatest tools you can give them is coins, because they can learn how to skip count by 5s, 10s, or even 25 cents. They also understand this idea of place value, that in 25, there's also 2 10s and 5 1s. They also learn equivalent, right? So if I don't have a quarter, I could use 5 nickels or 25 pennies. So for kindergarten, 1 by 1, first graders, groups of 10s, second graders, understanding those equivalent values and groups of 100. So by the end of the year, second graders should be adding and subtracting with numbers up to 1,000. First graders should be adding and subtracting up to 100. And the Common Core standards say that kindergartners should be adding and subtracting up to 10, although most of the kindergartners I've seen at Cabrillo are beyond that point. What we don't want to teach, and I will tell you why, It becomes more and more clear to me every day is we do not want to teach second graders this one. I'll make it.
Yeah, that was my question. Thank you for
Yeah.
bringing it up.
And that, and I'm gonna tell you why, and let me tell you why. Because 2 reasons. When you look at this, all they have to do is 7 minus 5. So all they have to do is count up to 7 and subtract 5 and do 3 minus 2. It's a quick way to the answer, right? I think about it as like a microwave. You can cook your dinner in the microwave and it'll get done and it'll get cooked. It takes longer than the stove or the oven, but I think we all know the difference between a microwave cooked meal and an oven cooked meal. Secondly, the other thing is we're having kids work on a number line. So they could do 37 minus 25 on a number line. There's so much more math and number sense in a number line than in this. This is actually the 4th grade standard. So leave that to the 4th grade teachers. So what we're finding is that if we put 37 on a number line and ask the kids to count backwards, they're having a really hard time counting backwards. Really hard time. The other beautiful thing, so we want them to be able to count backwards. This strategy does not support counting backwards. The other beautiful thing about the number line, really quick, is that you could do 37 minus 25 on a number line by going backwards and subtracting 25, for instance. 1, 2, 3, 4, 5, and then we could subtract 10, and then we can subtract another 10. But kids could also learn on a number line, but here's the thing. Well, let me say this, that you can count up, right? So 25 plus 5 more will get us to 30, and 30 plus 7 will get us to 37. So the distance or the difference between is 12. This is very sophisticated thinking for kids to know that they can start at 25 and count up to 37, or start at 37 and count down. But the kids who learn this strategy won't do it. It's like pulling teeth. It's too long.
Can you also give us an example of where the 1st graders should be at?
For subtraction?
In addition, I know you said that they should be able to add and subtract all the way up to 100.
Yeah, right now I would say 1st graders are right about this age right now. 37
Okay.
and 25. Some teachers are starting to introduce the number line. Most teachers are using base 10 blocks right now.
Okay.
So kids are going 10, 20, 30, 31,
Right.
32, 33, 34, 35.
Okay, gotcha.
37. Yeah, it's perfect
Okay. Yeah.
for where they
Thank
are.
you.
Yeah, just stay away from that one.
We will.
That was
Any
a good
other
question.
questions?
We can take more questions. I just wanted to thank you. I know some of you probably are approaching the end of your time you're able to stay. So we'll stick around if you have questions, but I just want to say thank you everyone for being here, and thank you to Danielle, and we will post the recording. So thank you.
For sure.
You're welcome, Ms. Wilberg.
Thank you.
Bye.
Bye. Thank you.
But certainly any other questions.
Mhm.
Thank you.
Thank you. Thanks, Eddie.
Thank you so much, Danielle. Have a good afternoon.
You're welcome. You too.
Thank you.
I actually have a question. I have a 2nd grader and I was kind of teaching him that strategy you were doing with the number line.
Oh, yeah.
Is it okay to teach them that, or are they supposed to come up with it on their own?
What I say to kids is, for example, so first of all, I'm going to give them a number like this so that they don't have to regroup. So what I mean is I would do something that's simple
Mhm.
first instead of doing something like 32 minus 28. So start with a number that's fairly simple and say, what would that look like on a number line? Let's try it. what number would you start with, right? So some kids might think about starting at 25 and counting up. Some kids might think about 37 and counting back. But all I do is I pose the problem. I pose the problem and ask them, what number do you want to start with? And then we go from there. If they make a mistake, I say, it's okay, we could just revise it. Let's try another one.
Mhm.
So, but in general, they can usually do it.
Okay.
It's a nice one. It's a good one. Really good number sense.
Yeah.
Mhm.
Okay. Thank you.
You're welcome. That's a good turnout.
That was good. Any last questions? Otherwise, I'm going to thank you all and say goodbye. And we'll do it again sometime. It was good to see everyone. Thank you. Thank you so much, Danielle.
Thank you,
Welcome.
Danielle. Thank you, Wilbert.
Thank you all. We have some questions. So any resources that I get, we'll make sure that we send out. I can put them in the newsletter in a little math section with any resources from Danielle that'll take you to her website and to some of the resources that she has there, such as the problems that she was talking about earlier. Anything she gives me, I'll make sure I put out in our newsletter. So thank you so much, everyone.
Bye.
Thank you.
Thank you.